Reach out your hand and move it through the air. Notice the space you are interacting with. You can push up, pull down, sweep left, right, forward, and backward. For your entire life, your brain has processed reality as a vast environment filled with depth, height, and width. When you look up at the night sky, you see a universe expanding in every possible direction. But consider the possibility that this perception of depth is a physical illusion, a highly convincing projection played on your consciousness. Theoretical physicists mapping the outermost edges of quantum mechanics have encountered a mathematical anomaly. The equations governing our physical reality resolve much more cleanly if the universe is entirely flat. This is known as the holographic principle. It suggests that you, your world, and the entire cosmos are a three-dimensional projection, generated by two-dimensional data stored on a distant boundary. To understand how this works, we have to look at the most extreme gravity environments ever discovered, black holes. In physics, there is an absolute law regarding information. If you burn a book, the physical object is destroyed, but at the quantum level, the data that made up the book still exists in the smoke and ash. Information can be altered, but it cannot be deleted. Black holes create a massive problem. When an object crosses the event horizon boundary, it is pulled inward and disappears. The quantum information seemingly vanishes. If a black hole actually deletes data from the universe, the most basic laws of physics break down. The mathematical framework holding reality together would collapse. This contradiction is called the information paradox. Generations of the greatest minds on Earth, including Stephen Hawking, spent decades trying to resolve this specific error in the math. Resolving the paradox required physicists to abandon the standard rules of dimensional space. The math eventually revealed a surprising answer. The quantum information of an object never actually falls into the black hole. As a physical object hits the event horizon, its three-dimensional structure is destroyed. The quantum data is flattened and smeared across the two-dimensional surface. Think about a credit card's magnetic strip. That flat strip holds massive amounts of complex data: your identity, bank details, and financial history. A black hole operates using the same mechanic. The three-dimensional interior doesn't actually matter. The true reality of everything it has ever consumed is stored entirely as raw data on its flat exterior. Physicists then applied this logic to the scale of the entire universe. If a black hole's surface stores its contents, they asked if the cosmos itself possessed a similar boundary. Just as a black hole has an event horizon, our observable universe has a cosmological horizon, a limit set by the speed of light beyond which we cannot see. This boundary acts as a two-dimensional shell surrounding everything we know. According to the holographic principle, all the quantum source code required to generate Earth, the galaxies, and human beings is permanently etched onto that distant, flat, two-dimensional shell. The reality we experience, including gravity, the passage of time, and spatial depth, is a holographic projection radiating inward from that outer boundary. This raises a question of architecture. Why would the universe operate as a flat projection rather than a physical 3D space? Scientists have observed that the mathematical structure of the holographic principle mirrors the logic used in computer simulations. In digital environments, rendering a truly infinite 3D world down to every single atom carries an immense computational cost. A system attempting this would face significant limits on speed and storage. Storing all universal data on a flat 2D surface and projecting only the necessary three-dimensional information is far more efficient. The system renders the depth only as it is perceived by the observer. This suggests an underlying architecture centered on data efficiency. What we perceive as physical depth behaves exactly like an optimized rendering trick. This redefines your own physical existence. You are a biological decoding machine, navigating a stream of information. Your brain functions as a quantum receiver. It pulls in that flat, two-dimensional data and renders it into a highly convincing three-dimensional simulation. Much like a hologram on glass, where a flat image contains all the data needed to create the appearance of depth, consciousness acts as the light shining through a two-dimensional grid of cosmic code. Distance and depth function as an interface. translating flat code into the immersive world we touch. True reality remains flat, encoded, and existing completely out of our physical reach.